So this is the fourth video on on chapter 4. This is going to be on the periodic table and ion charges and ionic compound, how to write formulas for ionic compound. So Dmitri Mendeleev, at this time there were many elements already found, and he decided to order them by atomic mass. So from the lightest to the heaviest. And he saw a repeating pattern of properties among elements that were recurring periodically. So he stated the periodic law. The periodic law says that when the elements are arranged in order of increasing relative mass, certain sets of properties reoccur periodically. And so that led to the first periodic table. And so this allowed the scientists to see that the first periodic table that it was possible to make had some holes. There were missing elements there. And so by using the pattern of properties, scientists were able to predict properties of undiscovered elements. For example, germanium was discovered like that. All the elements around it were found, but germanium was missing. And so Mendeleev could argue that this element should have such and such properties. And when it was found, it was confirmed that germanium had the properties it was supposed to have. So this is a modern periodic table. At the time of Mendeleev, there was much less elements. This periodic table is not even the latest version, because you can see those elements like UUT, UUP, UUS, and UUO, 113, 115, 117, and 118 elements are still not named. But the colors here are suggesting similar properties, right? The pink, the light orange, the purple, the blue, all the yellow and green, all of these colors and names you can see here below the periodic table, that these have names that you will need to learn. These suggest similar properties. So there is a periodic table of video here, and there is a link below that it's www.periodicvideos.com, and that's quite interesting. I suggest you spend some time on it. So this is the periodicvideos.com website. And so when you click on each of the elements, there is a video that explains everything about that element. So I would suggest that you watch carbon, hydrogen, nitrogen, oxygen, and many others if you have time. You will learn a lot from looking at those. So, as I said, those names that are on the bottom here, you will learn them. But let's introduce you to them by team. So this periodic table shows you that we have cut the periodic table in blocks. And the first 2 columns on the left, plus the last 6 columns on the right, are regrouping elements that we can call the main group elements. And if you look at the previous periodic table, the number above those columns are the 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A on the right here. So it's the A groups. So these main groups elements are also the A groups, capital A group. Those columns that are smaller in height are called the transition elements. transitions elements are B groups. If you look at that periodic table, you see we start from the left with the 3B colon, 4B, 5B, 6B, 7B. There's 3 8B columns, then the 1B and 2B. So those transition elements are also the B groups. And then there is 2 rows here that are the inner transition elements. And these should be located, as you can see from this periodic table, they should be located where you see the colors here. Right after barium and radium, you should have all these 2 rows. And then the yellow block should come after that. So that means the periodic table should be much wider. So here I'm showing you a periodic table that really shows you where those 2 rows that are usually on the bottom, how they are actually between the first 2 columns on the left, and then all those B groups, and then the last 6 columns on the right. So the periodic table should be really wide like that. But you can see that it is more convenient to have those 2 bottom rows here under the main table, because otherwise it would be too wide. Right. So these are called the inner transition elements. So elements with similar chemical and physical properties are in the same column. That's how Mendeleev, constructed the first periodic table. It's by aligning in columns elements that had similar physical and chemical properties. And so those columns are called groups or families, because they are representing, elements with similar properties. They're designated by a number and sometimes a letter, and the letter would be A for the main groups. So remember how we said the main groups are the A groups, and the transition elements are the B groups. And so rows are called periods. So periods because the properties observed in elements reoccur periodically within the, the period from left to right. You see the same type of chemical properties come back. And that's why it's also called a periodic table, because you see a pattern of properties that are shared with elements in columns. So these are names you need to learn because often when we will talk about these groups, we will call them by their name, not necessarily by their group number. So to the left in orange, you see the alkali metal. It's the group 1A. Right next to the alkali metals are the alkaline earth metals in light orange. Then in the middle here, that are columns that are, smaller in heights. These are called the transition metals, or the B groups. Then to the right, we enter the 6 columns to the right, and there is no specific names for the first 4 columns, but then the column group 7A is called halogens. They are called halogens. And the last column to the right is representing the noble gases in purple here. Noble gases completely to the right. And then those inner transition elements that are the 2 rows at the bottom of the main periodic table, they are divided into rows, and the first row is the lanthanide and the second row is the actinide. So you need to learn these names so that if we talk about them, you know what we are talking about. Another classification that you get from the periodic table. So maybe you notice that the periodic table has a bold line that zigzags, from top to bottom, to the bottom right corner. This line is important as it shows the border between metals and non-metals. So to the left side of that line, you find the metals, and most of the elements are metals, as you can see. And then to the right of that line, you find non-metals. So it's the dark green. Here are the non-metals. And on that line, there are elements that are kind of in between in properties and behavior, in between metals and non-metals. And so we will call them the metalloids. So metalloids are elements that touch the stair-step line. Except, be careful, aluminum is not considered a metalloid, but a metal. And polonium is also considered a metal, not a metalloid. So there's only really 1, 2, 3, 4, 5, 6, 7, maybe 8 metalloids at most. So let's talk about the properties of metals. So metals are solids at room temperature, all of them except mercury. Hg here is the symbol for mercury. Mercury is the only metal that is liquid at room temperature. Here you see a picture of calcium, and you can see it's solid. You recognize that it's a metal because it has a reflective surface. They are shiny. Metals reflect light. They conduct heat, right? Think about all those pots and pans. They are made in metals because they conduct heat. It's helpful. They conduct electricity. Think about copper wires inside electrical wires, right? Copper is used in electrical wires to conduct electricity. Metals are malleable, which means they can be shaped, right? For example, pots and pans have been shaped into, those cylindrical shapes. You can shape them into sheets or post, all kinds of shape. Metals are ductile, which means they can be drawn or pulled into wires. So they can be pulled into wires, like the copper wires in electrical wires, or pipes, copper pipes for plumbing. So metals are ductile like that. About 75% of the elements are metals, right? You saw that most of the elements are to the left side of the stair steps, and that makes them all metals. So they are found on the left of the jagged line. Non-metals, as the name says, they have properties opposite to metals. And so non-metals are found in all three states, which means solid, liquid, and gaseous. And so if we look at the non-metals here, helium, neon, argon, krypton, xenon, and radon, all the noble gases here are, as the name says, gases. Fluorine, chlorine are also gases. Oxygen, nitrogen, and hydrogen are all gases. The solids are the carbon, phosphorus, selenium, iodine. And then the only liquid is the bromine, Br. So non-metals are poor conductor of heat, right, as opposed to metal. Non-metals are poor conductors of electricity, again, as opposed to metals. The solids are brittle, like selenium, iodine, phosphorus, and sulfur. I forgot sulfur. Carbon are all brittle solids. And so nonmetals are found in the upper right corner of the table, periodic table, right to the right of the jagged line, except hydrogen. So be very careful here. Hydrogen is found on the left side. It's the first atom in the upper left corner, but it's a non-metal. It's not a metal. So hydrogen is a non-metal. Then the metalloids, as we said, they are showing properties that are in between metals and non-metals. So they either are more like metals or sometimes more like non-metals. So they are also known as semiconductors. And silicon is a very good example of it. Silicon, looking by the picture here, is shiny like a metal, conducts electricity like a metal, but does not conduct heat very well like a non-metal, and it's brittle like a non-metal. These semiconductors are very useful to make all kinds of electronic devices. So very useful elements here, and they are found on the jagged line. But as we said, you have to be careful. Aluminum, even though it touches that line, is not a metalloid, and polonium is not a metalloid. So there's very few metalloids. It's boron, silicon, germanium, arsenic, antimony, Sb is antimony, tellurium, and astatine. So let's do a concept check here. Classify each element as metal, non-metal, or metalloids. And after you've found that about that, find any other ways that you can classify them as well. Please pause the video to work this out on your own before you watch the answer. This is the only way to learn by doing this on your own before you watch the answer. So, xenon. What is a xenon? A metal, metalloid, or non-metal? Xenon is found in the group 8A. It's so it's on the right side of the jagged line, which means it's a non-metal. So it's a non-metal. Being in a group, A group, means it's a main group element. And those elements in group 8A are also named noble gases. So xenon is a non-metal, it's a noble gas, and it's a main group element. Tungsten, symbol W, is atomic number 74, is found among the metals on the left side of the jagged line. It's also found among the transition metals in the B groups, right? So the B groups are called transition metals. Bromine, symbol Br, is on the right side of the jagged line, so it's a non-metal. It's in group 7A, so it's a main group element because it's in an A group. And that 7A group is named halogens. These are named halogens. Arsenic, symbol As, is on the jagged line, so it's a metalloid. And it's also in an A group, 5A, so it's a main group element. Cerium, symbol Ce, is found in those two rows at the bottom of the periodic table. Atomic numbers 58, is an inner transition element. It's a metal. All these inner transition elements are metals. And because it's in that first row of the inner transition elements, it's also a lanthanide. The second row is the actinide. So elements are found in their natural states. When they are found in their natural states, they are neutral, which means they are not charged, they are not ions. And so some elements are found as diatomic molecules, which means they are found as molecules made of two atoms of the same kind, right? So two atoms of nitrogen, for example, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. These are the 7 elements that are found as diatomic molecules in their natural state. And these are almost all gases except bromine. Br2 is a liquid, a brown liquid, and iodine, I2, is a purple solid. But all the others are gas. And so when you find them in their elemental state, they are always as diatomic molecules made of 2 atoms. But still, we will call them the same. We will call them like nitrogen, oxygen, fluorine, bromine, chlorine, iodine, and hydrogen. So a way to remember them is to think about the rule of 7. The rule of 7 that says you start at atomic number 7, which is nitrogen. You make the 7 figure by going to the group 7A, and you go down. So that means you have nitrogen, oxygen, fluorine. You go down in group 7A from fluorine, chlorine, bromine to iodine, and that's 6 elements there. And the 7th is hydrogen. So this is a way to remember which molecules are diatomic in their elemental state. And some elements are even tetraatomic, like phosphorus is found as P4, so 4 atoms of phosphorus bonded together. And some are octaatomic, like sulfur is found as a S8 molecule made of 8 atoms of sulfur. So ion charge and the periodic table. So remember that charge species can be positive or negative, right? Cations or anions. So how do we know which elements will gain electrons and which elements will lose electrons? And how many electrons will they gain or lose? So the periodic table is a powerful tool that gives you all these properties of metals and non-metals, and the names of groups because of similar properties. And elements actually will form the same type of ions if they come from the same type of group. So the charge on an ion can often be determined from an element's position on the periodic table. So from the position on the periodic table, you can tell for the main group elements only, you can tell what kind of ion they become. So one more general thing to say is that metals, they always form cations, right? Metals on the left side of the periodic table will make positive ions, and non-metal found on the right side of the periodic table are forming negative ions, anions. Not always though, they also form positive ions. But as a general rule, you want to remember that metals form positive ions, non-metals form negative ions. For the main group metals, so remember the main groups are the A group. And here it's really for only the 1A, 2A, 4A group. So let me add this. It's for the 1A, 2A, and 3A groups only. That this is true. The cation charge is equal to the group number. So all metals from 1A, 2A, and 3A groups will just have the same number of charge as the group number. And then For nonmetals, the anion charge is equal to the group number minus 8. So nonmetals, maybe you've noticed, they are all part of the main group elements, because it goes from 3A to 8A. And those nonmetals, actually from 4A to 8A, they form negative ions, which means you take the group number, and so for example, let's say 7A minus 8. 7 minus 8, it's going to be negative 1. So all these elements will form a negative 1 ions. So let's look at the periodic tables that shows that. So you have those group numbers 1A, 2A, and 3A. These are, it's for metals, right? These are metals. They are on the left side of the steps. And so the alkali metal, which are group 1A, form positive 1 ions. Group 1A means plus 1 ions. They are metals, so it's positive ions. And so lithium, sodium, potassium, rubidium, and cesium will always form positive 1 ions. Group 2A are called alkali earth metals. They will form 2 plus ions, right? 2A, 2 plus. So beryllium, magnesium, calcium, strontium, and barium will always be 2 plus ions. Then there is no rule for the B groups. For the B groups, you cannot predict what kind of ion they will become from their position in the periodic table. So it doesn't work for the B group. And then you reach the metals from the 3A group. And there it starts with aluminum, gallium, indium, and thallium will form positive 3 plus ions, right? Group 3A, so 3 plus ions. That's only for the metals, so below the steps, right? It doesn't work for the 4A or 5A metals. Then for the non-metals that are on the right side of the periodic table, notice how the noble gases, helium, neon, argon, krypton, xenon, and radon, they do not make ions. These are inert, which means they never tend to react. They stay as single atoms. So they don't make ions. And so halogens in group 7A, 7 minus 8 means they are going to be negative 1 ions. The fluoride, the chloride, the bromide, and the iodide ions. Elements in group 6A will form negative 2 ions because you do 6 minus 8, it's negative 2. And there you have oxygen, sulfur, selenium, and tellurium. So tellurium, being a metalloid, still is included here. So these are negative 2 ions. And then in group 5A, you do 5 minus 8, it's negative 3. And here you have the nitride ion and the phosphide ion with 3 negative charges. So you want to remember this. So make like a mental picture of this. This is important to remember. So ionic compounds. Here we will finish with ionic compounds. There are 2 types of compounds that can be formed between elements. The first kind are called covalent, and we'll talk about these in chapter 12, and ionic compound. And so as the name says, ionic compound are a compound that results when a metal reacts with a non-metal to form cations and anions. So it's a compound that is made of ions, right? And ions are easily made from metals, and metals like to make positive ions, so cations, and non-metals like to make negative ions. And because positive and negative charges are attracted by each other, those cations will attract those anions and form compound, and that's how they bind together. They bind due to the electrostatic attraction between positive and negative charges. However, the formulas for ionic compounds must be neutral. You know, once the ions are bonded together, the ionic compound itself is neutral. So the cation charge exactly balances the anion charge, right? You need as many positive charges as you have negative charges to form the formula of your compound. And that's the key principle that allows you to write formulas for ionic compound. So let's practice writing formulas for ionic compound. Let's say you have these combinations of ions. I want you to pause the video so that you are practicing this before you watch the answer. It is important that you practice on your own before you watch the answer so that you learn. So, what will be the formula of the compound formed between the sodium ion and the chlorine ion? So you want to look at your periodic table, find the sodium. Sodium is in group 1A, it's an alkali metal, atomic number 11. So group 1A, metal, so that suggests it makes a positive 1 ion, right? Metals makes positive ions, and group 1A means +1 ions. Chlorine, found in group 7A on the right side of the periodic table, is a non-metal. Group 7A suggests 7 minus 8, it's going to be a -1 ion. So Na plus Cl minus, they each have 1 negative charge and 1 positive charge. And so they will cancel out when you put them together. So the compound formula will be NaCl, because 1 Na plus will cancel the 1 negative charge from the chlorine. Okay, let's look at barium and oxygen. Barium in group 2A is an alkali earth metals, is making a 2+ ion because it's in group 2A and it's a metal. So 2+ for barium. Oxygen, a non-metal found in the right side of the periodic table in group 6A. So it's a non-metal, so we do 6 minus 8 is -2. So oxygen will have 2 negative charges. So barium, 2 positive charges, oxygen, 2 negative charges. It's exactly the same amount of positive and negative charges, so they will cancel out. And you need only one of each of the elements to make a neutral formula, BaO. Let's look at potassium and phosphorus. Potassium is capital K, atomic number 19, in group 1A, an alkali metal. So group 1A, metal, so it's going to be +1. And phosphorus, found in the right side of the periodic table, non-metal from group 5A. You do 5 minus 8, it's -3. So we have K plus and P, 3 negative charges. So here you have 1 positive charge on 1 potassium and 3 negative charges on 1 phosphorus. So to balance out the 3 negative charges on the phosphorus, you will need 3 potassiums, right? So we could write here another K plus and yet another K plus. K plus, right? And we see that if we have 3 K plus and 1 P -3, we will make all charges cancel. So that means you need 3 potassium for 1 phosphorus. And so the subscript 3 here, indicates you have 3 potassium and 1 phosphorus. Another way to do this is by doing what we call a crisscross trick. That allows you to take the charge of the phosphorus and put it as a subscript for potassium, and take the charge of the potassium and give it as a subscript for phosphorus. And so that means the 3 from the P negative 3 will become a subscript for potassium, and the 1 plus from potassium will become a subscript of 1, which is implied and not written for phosphorus. So the correct formula is K3P. Let's look at magnesium and nitrogen ions. Magnesium is found in group 2A. It's an alkaline earth metal. Group 2A, which means it's going to be a 2 plus ion because it's a metal from group 2A. Nitrogen is a non-metal found in group 5A on the right side of the periodic table. 5 minus 8 is negative 3. So here you have Mg2 plus and Mg2 plus and N3 minus, right? So when you have 2 pluses and 3 minuses, the common multiple here will be 6, right? You cannot simplify that. So make it 6 positive charges in total and 6 negative charges in total, and they will cancel out. So to get 6 charges, 6 positive charges from Mg2 plus, you will need 3 Mg2 plus. So you will need another Mg2 plus, and yet another one here, Mg2 plus. And those 3 Mg2 plus will make 6 positive charges in total. And then the nitrogen, to make 6 negative charges, you need only one more, because one is 3 negative charges and another one makes 6 negative charges in total. So this way, you see that the formula should be Mg3 N2, right? 3 magnesium ions and 2 nitride ions will make this neutral formula. You can also use the crisscross trick, and let me clear first. The crisscross trick here will show that the 3 from the nitride will go as a subscript for magnesium, and the 2 from the magnesium will become a subscript for the nitrogen. And you see that you get Mg3 N2. This is called the crisscross trick. Usually works well. Let's try now with aluminum ions and oxygen ions. Aluminum is found in group 3A. It's a metal, even though it's touching the stair steps here. We know that aluminum is a metal. Think about aluminum foil, and you can definitely tell it's a metal. So in group 3A, metal, so it's going to be 3 plus. Oxygen, we already found that oxygen is a non-metal in group 6A. So 6 minus 8 is negative 2. It's going to be a negative 2 ion. So aluminum and oxygen, so Al3 plus and O negative 2 will give Al2O3. So here again you can do the crisscross trick that shows that the 2 from oxygen will become a subscript 2 for aluminum, and the 3 from the aluminum will become a subscript 3 for oxygen. Or you can also see that, again, between 2 and 3, to make this the same number of positive and negative charges, you need to go up to 6. And so you need 6 positive charges. And here you have already 3 with 1 of the aluminum. So you would need another of the aluminum ion. That's going to be 6 positive charges. And then oxygen, you have 2 negative charges per oxygen. So with one more, it's going to be one more, it's going to be 4 negative charges, and one more is going to be 6. Sorry, this is not placed where it should be. And another 4 negative 2. So we need 3 oxide ions to have 6 negative charges in total, and we need 2 aluminum ions to have 6 positive charges in total. And so the formula is then Al2O3.